Okay, so on problem 2, particularly 2a and 2b, the concept that we're going to use repeatedly is this limit that we saw in class today, namely that as x tends to 0, the limit of sine x over x, this is indeterminate, right? It's 0 over 0, but this limit actually, it converges, and it converges to 1. And so this is the concept we're going to use over and over in particularly in parts A and B of 2. So looking at part A, we have sine 3x over 2x, and we have the limit as x goes to 0. Now, my goal is to sort of rework this so that eventually I'm looking at the limit as 3x goes to 0 of sine 3x over 3x. Because we know that this limit is going to be 1, and it simply follows from this fact. Okay, so my goal is to rework this so that finally I'm looking at an expression like this one. So the first thing I do is I'm going to try and get 3x down in the denominator. So I do that by multiplying and dividing by 3. And then in the next step, I move things around so that I have sine 3x divided by 3x. And then what I'm left with is a factor of 3 over 2. So go ahead and check that algebra. And then what I can do is just bring the 3 over 2 outside the limit. It's just a constant. It doesn't matter. And I can rewrite this limit as x goes to 0 instead as the limit as 3x goes to 0, right? Because if x goes to 0, equivalently 3x must go to 0. And now we have exactly what I want because we know that this limit must be equal to 1. And so that gives us the overall answer of 3 over 2.